Okay, so in this problem that they're asking that if ABC are natural number, then the probability that a square plus b square plus c square is divisible by 7 is m by n. Then they are asking value of m plus n, where m and n are relatively prime numbers. Okay, so in this case we can start with, like, if any number is divisible by 7, so the remainder possibilities are 0, 1, 2, 3, 4, 5, 6. That's it. So these are the possibilities of remainder we have, right? So if a is any natural number, we can write in terms of, let's say, 7k plus 0. If we square that, then we'll get 49k square, and if we divide that number a square by 7, that remainder we are getting is 0. Suppose if we choose a as of type 7k plus 1 type, so if we square that number, we'll get 49k square plus 14k plus 1. So that remainder we are getting is 1. In the same way, if we choose a is of type 7k plus 6, after squaring, we'll get these two factors as a multiple of 7 and 36. So when we divide this by 7, a square, when we are dividing by 7, then the remainder we are going to get 1. Then, so for remainder 1, we have two choices basically. Either we are taking number as 7k plus 1 type or 7k plus 6 type. Now, if we choose a to be of type 7k plus 2, after squaring, we are going to get again 49k square plus 28k plus 4. So the remainder here we are getting is 4 when we divide a square by 7. Correct. Now if we choose a to be, let's say, of type 7k plus 4, let's say. So if we choose a to be of type 7k plus 4, then a square, these two terms will be multiple of 7, then 16. When we divide this a square by 7, so again we are going to get the remainder. Okay, so this time we are going to get the remainder 2. Okay, now if we choose a to be of type 7k plus 3, so if we are taking 7k plus 3, then if we squaring, then these two terms are multiple of 7 and this is 9. When we divide this by 7, we are getting remainder 2. Correct. And if we are choosing a is of type 7k plus 5, then after squaring, these two terms will be multiple of 7 plus 25. When we divide this, then we are getting remainder 4. So basically, and 7k plus 6, so we have used all the cases. So ultimately the remainder we are going to get when we are choosing a to be of type 7k plus 1, 7k plus 2, 7k plus 3, 7k plus 4, 7k plus 5, 7k plus 6. So in all the cases, we can conclude easily that remainder we are going to get 0, 1, 2, 4. So remainder 0 we are going to get only in one case, when we are choosing a to be multiple of k, b also multiple of k, and c also multiple of k. So only one case when we are going to get that remainder 0. So that is only one case when the remainders of a square is 0, remainder of b square is 0, and remainder of c square is 0, when we are choosing a as a multiple of 7, b as a multiple of 7, as well as c as a multiple of 7, right? So this is the case we are getting. Now suppose remainder 1 and remainder 2 and remainder 4. So when let's say a square has a square remainder 1 means we are saying when a square is divided by 7, then the remainder we are getting is 1. So when a square is divided by 7, then the remainder is 1. So if a square remainder, when I am saying, I mean when a square is divided by 7, then remainder is 1. When b square is divided by 7, then remainder 2. And when c square divided by 7, then remainder is 4. So when we add all the remainders 1 plus 2 plus 4, we are going to get 7. That is again multiple of 7. And what we are looking for? We are looking for the probability such that a square plus b square plus c square is divisible by 7. So in this case, when remainder 0, if we try to calculate the probability when remainder 0, only one case favorable, so that is 1, and divided by 7 cube we can write. Now that remainder is 0, then again remainder 0, then only it will be again multiple of 7. So a square plus b square plus c square will be divisible by 7. So if we choose when a square divided by 7, we are getting remainder 1. When b square divided by 7, we are getting remainder 2. When c square divided by 7, we are getting remainder 4. When we add all those remainders, then we are getting 7. So ultimately in this case, we are getting a square plus b square plus c square is divisible by 7. Now how many such cases possible? We can simply say that if we choose a of type 7k plus 1 or 7k plus 6 type, in that case we can get remainder 1 when a square is divided by 7. So 2 cases. Same for remainder 2. Now same for remainder 2 is possible when we are choosing that number as 7k plus 3 type or 7k plus 4 type. So this is also 2 cases, right? Now, so these are 2 cases. And for remainder 4 also we can check that for remainder 4 also we have when a is of type 7k plus 2 or a is of type 7k plus 5, then only it is possible. So we are getting for this also 2 cases. So 2 into 2 into 2, and total cases that when we are writing this is when a is of type 7k plus 1 or 7k plus 6, it can be b, it can be c also. So we can arrange these in 3 factorial ways. Basically we are arranging this 1, 2, 4 in 3 factorial ways. And for remainder 1, there are 2 cases which are supporting. For remainder 2 also 2 cases, and for remainder 4 also 2 cases. So the total cases in this case we are getting 8 into 6, that is 48. So again for another way we are getting remainder 0 basically, because we are adding remainder of a square plus b square plus c square individually when they are divided by 7. In that case we are getting again multiple of 7. So probability if we write for a square plus b square plus c square is divisible by 7, in this case we are getting 48 favorable divided by 7 cube. Now next, if we choose from here that the remainders are possible 0, 1, 2, 4. So either remainder 0 we are getting directly in this case, or when we add 1 plus 2 plus 4 we are again getting 7. So again this is divisible by 7. Now next, if we are getting another multiple of 7, let's say 14, but 14 is not possible. Reason being that the maximum remainder we have is 4. So 4 plus 4 plus 4 if we do, so that is 12, not 14. So for getting multiple 21 is not in the picture because we are not getting even 14 also, correct? So these are the possible cases we have. So either remainder, that again we are saying that this, either in this case when ABC all are 0, so ABC all have remainder 0 means ABC all are directly multiple of 7, or otherwise they are of this type 7k plus 1, 7k plus 6. So our required probability we have, so the required probability we have is 1 by 7 cube plus 48 by 7 cube, that is 49 by 7 cube. 49 is nothing but 7 square by 7 cube, so 1 by 7, that is m by n. They are asking m plus n, so answer is 8. So I hope this is clear.